the definition things. So that way you have more of an understanding of them apart from just words and definitions on a piece of paper. So I'm just going to go through each one, and some of these you'll obviously already know because you probably have experience with them, or maybe they don't need as much in-depthness. Feel free, obviously, to take notes. So After Effects is a program that is used for compositing 2D imagery together. If you've had the After Effects class, the motion design class, obviously we created stuff in there, and we didn't really do a whole lot of bringing 3D into it. But After Effects has a huge role in what we do in 3D, apart from just making motion graphics. Imagine that you have an image that you want to draw inside of Photoshop. After Effects is basically we can take our stuff that we've rendered out from Cinema, bring it in After Effects, and tweak a whole bunch of stuff inside of it. Okay?
Hi.
Hi.
Sorry.
No problem. So we can do some limited 3D things. Now, the cool thing about Cinema and After Effects is that they're actually somewhat friends. You could actually export stuff out of Cinema and bring it right into After Effects so that your cameras, your lights, and your basic object placement is already there. What's neat about that is, let's say you're doing your title sequences like we're doing now, and you wanted to put a picture of a dog in the background, but you forgot to. You can actually export your file out of Cinema, bring it in After Effects, and then you can place that picture of a dog behind all of your stuff, and your camera moves and everything else will match up perfectly, which is really awesome. Okay? So eventually, if you keep playing with the stuff, you'll get into that area. Ambient Occlusion. This is basically a way for us to make stuff look like it actually has a little bit more contact with the objects and a little bit more depth to it. So what we would typically do is when we rendered out like our room, you may have noticed that around like the edges where the shadows would be, where one object is touching another object, it doesn't really look like those two things are touching as much as they should. So what we could do is render out what's called Ambient Occlusion. And this is a black and white image where every time you have one object close to another object, it renders out these dark areas. We could then use that inside of After Effects to darken the areas of where things touch and give them more presence so it feels like they're actually having more contact. So if you look at this here, this is, that's a sketch. This is the Ambient Occlusion and the shadow. So you see how dark this is here. This is going to give you a lot more depth than otherwise. Here's actually a good example. So this is without Ambient Occlusion, so everything looks kind of like it's like washed out. With the Ambient Occlusion, the areas that should be dark are extremely dark, okay? So you really get a better sense of it. What the Ambient Occlusion would typically look like is a lot of white with some harsh black areas and then some gradation in the middle. You can see in these, this is a pretty good example of some white with some black, nice and smooth. Here it's a little bit chunkier, or even something like this. This is a good example of Ambient Occlusion. This is too gray to be used as Ambient Occlusion, okay? So it's basically something that is white and black. We'll actually be using this later on, so it's not going to be something you won't touch in this class, but I just want you to see it. There's actually other things that we would render out as well. So Ambient Occlusion is one of those things that we could actually render out as a separate thing to add to our stuff to make it look better. You could actually separate the stuff out. So we're adding, like to ours, we're adding shadows inside of Cinema. You could actually render out shadows separately and add them in afterwards. That way you can control what the color looks like, the darkness of them, the softness of them, everything. You could even add the color separately. So here is the rendering. You could actually render out each light individually. You could render out the specularity separately. You could render out the subsurface scattering separately, the reflections separately, the normals, different shadows, ambient occlusion, depth, and masks, and put all those together inside of Photoshop or After Effects to actually make that final image. Now, we're not going to get into anything this level in this class, but the further you dive into 3D, the more this stuff will come up and the more you'll be doing that kind of thing, okay? Anti-aliasing, that's where the edges of our stuff, we haven't really probably seen it too much, but if we were to create a sphere, I Shift-R'd this, and I zoomed in. So this is anti-aliasing. Aliasing is like the stepping of those pixels of where the edge would be. Anti-aliasing blends the background and the foreground, so we get this nice transition between that. Depending on what your settings are under anti-aliasing, you would get, let's say I set this to none, because it'll probably look ugly. There you go. Super harsh edges. That's not going to look nice anywhere. Okay? Even as I zoom out, you can see how pixelated and edgy this looks. Oops. With just the default set. There you go. It looks okay. The more involved your geometry is, the higher up you have to take those settings. Okay? So on this object, it works perfect. If we had something like fur or hair, which is really fine, we have to crank up those settings a whole lot in order to make sure we capture all those strands, because there's so much detail we want to make sure we don't lose. Okay, we can set this to best, and then we have even more options here. And there. That should be good. All right, let's just see what that one looks like. Now, every time we take our settings up, look what's going to happen to this. It's going to take longer to render our stuff out, right? So, our default of geometry worked pretty good for the first one. I think we may even set it to best for their final render. When we get into higher end stuff, you can see how long this is taking for just a sphere. And if I go back to this image and that image, in this specific case, it's very minimal as to what it's actually doing. If you had a larger image, you're rendering this out to be put on a billboard, you need to make sure that your stuff is tight, okay? So that's where these settings are. Axis we've already looked at since the first day we were in there. You know, we move it in the x-axis or the y-axis or the z-axis. That's what we're doing. We're rotating something around a specific direction. That's what referring to the axis is. The axis can be moved also. I believe we've talked about that too. So if I wanted this axis to be somewhere else, I can hit the L key. Oops, I have to hit C first, then hit the L key. There we go. Then I can move the axis back here. And now basically it's going to be pivoting from this point. Ooh. Okay, fancy. Backface culling. I'm going to show this in Maya. It's a little bit easier to see. So in Maya, this is wireframe mode. Okay. Looks very similar to cinema, obviously. I can see the back faces of this. So if I were to marquee, I marquee the back and the front of this object. All right. So what backface culling will do is it'll turn that feature off. So only the stuff that I can actually see in front of me is visible. Oops, there it is. So now see how as I spin around this, I can't see those back faces on there. When I go into wireframe mode, there it is, I can't see them. And when I marquee, it marquees just the, it will marquee everything, but it'll only show me the front stuff. Okay, so that's what backface culling is. It's a great way to be able to, when you have a character and you have a million faces in front of you and a million faces behind you, it can get very confusing. So turning that feature on will hide a lot of that stuff. And there's other options you can set where it won't even select the stuff that's on the back side, which is obviously a nice feature. Box modeling is the way that typically things get modeled. I'm going to do this in Maya just so we can see it. I'm quicker modeling in Maya, so that's why I'm jumping to that. So we start off basically with a box, and instead of going through the process of trying to create something from a high definition shape, I do everything with starting off with this box. Oops. There we go. So whatever that's going to be, and then I can smooth it out and make it nice and smooth like that. Now, I wouldn't want to start off, I guess I duplicated that somewhere. I wouldn't want to start off with, let's say, a really high definition shape and try to move all the points around, because it never ever works. Like, just to show you, somebody modeling this may want to start off with a sphere with a lot of divisions. And they may do something like this, and then they're trying to move points. And so they're like, okay, well, I'm going to grab these points and try to move that, and then this point, try to move this. Nope, that's not going to work. There's way too many points here to even consider doing something like that. So typically start off with the lowest form, which is this box, and then you build off of that. Even a character's head, you'll typically start off with a box and then add divisions as needed. Box modeling. So here is a cube. They've rounded it to get this sphere. Now that's a different division sphere, which we'll talk about in a second. And then they've added the face stuff here. Here's another one where they've smoothed it a little bit and added some divisions. Here's a character where they start off with a cube and kind of rounded it and then added the character. Okay, so box modeling is typically the best way, for me at least, I found, the best way to model stuff. Start off with a cube and then start going from there. Okay. Bump mapping is a way to give something the appearance of actually having depth to it without actually putting that definition in there. Okay. So there's a lot of little tricks that happen inside of 3D. If I have a sphere like this, and I see the points, there. If I wanted to add some sort of definition into this area, I can't do that unless I actually have points in that area. Okay? I need divisions. I need something there. So I would have to go to, let's say, my knife tool, and insert a loop, and then go here, and there, and here. And depending on the kind of definition I want, I may have to add a whole lot of lines in this area in order for me to be able to grab one of these points and put something in there like that. Okay? Now, when we zoom out on this, I turn that off for a second, you'll see that it really only is like a little indicator. Like there's obviously something bumpy on that surface, but it's nothing that's like protruding immensely. Okay? A bump map is basically an image that we can put onto the sphere that will make it look like it has depth and look like it has detail without actually having that detail. So this is a tool we use in our later classes. It's called Substance Painter. And the cool thing about it is that it can generate bump map, color map, reflection maps, all these different kinds of textures to make our object look super duper awesome. So I'm just going to close this. I'm going to make a new project. Distributed. Yes. Okay. So this is going to bring in one of my projects here, which is a gear. I'm just going to hide this and that. Okay. Actually, I'll hide all of these except for one. Let me just grab this one and say solo. There we go. Okay. Real quick, I'm going to hit this. Yes. Okay. And this will give us an indication, too, as to some of these other things that we're talking about. So this is just a plain gear. I modeled it inside of Maya, and then I exported it as it's called an OBJ file. It's a file that allows me to go into other 3D softwares. Now, what this area is here, which we're going to talk about in a bit when we get to the U's, is the UV. And it's basically when we take a 3D object and we want to put a picture on top of that 3D object, we have to have a way for it to understand how do I take this flat image and wrap it around this 3D item. Okay, so that's what the UVs do, is tell it how to do that. Now this thing that I'm doing here, the cool thing about this software is actually going through and trying to figure out some specifics about the software or about the model and what it consists of. What's the thickness of it? What's the curvature of it? Where are the bumps already on it? What is the ambient occlusion? Like, where are these areas touching? And it'll use that to create the texture for the object. Okay? So once it's done in a second, there we go. Okay. I'm going to just turn that off. Scroll down here. Okay. So this is my gear that I have. I don't have a backside on this because you don't see the back. If I hit B, it's showing me the different items. Okay. So this one right here, that's ambient occlusion. So see how as the surfaces are close together, it's creating those dark lines around it. This is curvature. So as the surface is rounding, it's picking that up. This is position. We don't need to worry about that. Here's thickness. So it's actually reading the thickness of the surface in certain areas. And then that's back to the beginning. Okay. So what this is going to do now, I'm going to take one of these materials. And I will pick my favorite one, which is this yellowish one. right there. And I'm just going to drop it onto this. So it's very much like Photoshop, but it's in 3D. So you're like painting textures on 3D objects. So this should make that look like a rusted piece of metal. Okay. Now as I spin around this, it looks like right here that this is all kind of bumpy, right? Like that doesn't look like it's just flat. It looks like it has some detail. It's totally flat on my model. If I just turn this off, you can see that's perfectly flat. But that texture has a bump to it, and that bump is what's making it look like it has that detail there, okay? I could even emphasize that a bit more if I go into, let's say, my rust layer, and I go to my parameters here. There, rust. Let me make sure it's rust. Yeah, it's rust. Okay. I'm gonna take this contrast up some. Take the height position up some. There we go. So now we really have a lot more bump to this. Okay. So this is a program that will generate these maps for us. In this class, we're not going to get into this program. We will generate our maps by ourselves, but I want you to see that how we would do that, okay? So if we were to look at what this looks like, this is just the color, okay? So this is a color map, or if we go to our definitions, I don't have that one in there, do I? I don't. This is our diffuse map, okay? Here is the bump map. So this is what's actually bumping out. So wherever it's white, like 100% white, it's bumping out all the way. Wherever it's black, there's no bump. And then wherever it's in the middle, it's kind of like half bumping it, okay? So just imagine just like a mask, black and white. Black, there's no map, there's no bump. White, there is. And then in the middle, there's other stuff. So that's what's making it look like it's bumpy, is just that item there. Sweet. All right, so that's what a bump map is used for. Cinema 4D obviously is a 3D program for making 3D stuff. The benefit of Cinema over other softwares like Maya is the motion graphics features of it. Its animation stuff I think is okay. Its modeling stuff is okay. I would rather model in Maya. I'd rather lay out my UVs in Maya. But for motion graphics stuff, so far it really hasn't been touched. Okay, even Maya has motion graphic stuff. It's not as good as Cinema stuff. Cmyk is a color mode, cyan, magenta, yellow, and black. If you've had any design classes, I'm sure they've talked about that before. Or Photoshop, they've talked about that before. We are strictly dealing with RGB. Our stuff for what we're going to do in the class is we're working in RGB, we're rendering our stuff out, it's going to show up on monitors. If we were to print it, we would convert it to Cmyk just so it looks appropriate. Direct illumination. In the real world, a light hits a red piece of paper, and then what happens to that light? It bounces, right? In 3D, we don't have that by default. In 3D, it hits that red piece of paper, and that's it. It just stops. It lights up that red piece of paper. That's direct illumination, okay? Indirect illumination, or global illumination, is that. It hits the piece of paper, and then it bounces off, and then we have color bleed, and that kind of thing. So this is important for us because if we have it, let's say, an office or a little room, we have a lamp in the middle, and we turn the lamp on. In the real world, it would light up the entire thing. There would be some light that hits the walls, and it bounces and it fills in all of these other areas. In 3D, it doesn't do that, okay? So a lot of times we have to fake that bounced light. So we may have to add little lights throughout our scene just to fake in some of that bouncing, okay? Displacement, all right. So this is a bump map. It fakes it actually being bumped out, okay? So what that means is, in Cinema, that's where I had it. In Cinema, this little bump right here is perfect because when I go to the side, you really can't see it, or that side, you really can't see it. Now, if I wanted something that was more pronounced, like this, sticking out of the side, okay, you can actually create a map that's very similar to the bump map that would actually pull stuff off of the side of it, okay, and that's called the displacement. And you could actually take stuff that is just like your cube or a sphere, add a displacement map to it. Actually, I have to type displacement map. And it'll actually create more of a high-res piece of geometry. So in this case, we have, there's this dinosaur. And then down here, we have the displacement. Oops. So what the displacement is it's still a black and white map, but it's different, okay? The bump, in a bump map, black is 0 and white is 1. In a displacement map, 0.5 is no movement at all. 1 is a lot of movement. 0 is inward movement, okay? So 1's going to move outward, 0 will move inward, all right? So that's where you're going to get this ability to push your surfaces either way. So this dinosaur here, if you look at this, this is nice and smooth. In the rendering of it, it's actually bumpy. That's a displacement. Now on here, he may have a displacement and a bump map that's contributing to the end result, but this kind of movement here is only created by a displacement, okay? Super handy for doing this kind of stuff. There's a software called Zbrush. And what Zbrush allows you to do is more closely than any software we've had pretty much up to date. You've never been able to go in there and tweak fine details on things. If you wanted a character and you wanted them to have skin pores and you wanted them to have like moles that are actually like bumped out and not just colored, anything, a little scratch on their skin, you couldn't do that before without really faking it, okay, or adding a lot of geometry. Zbrush allows you to do that. It allows you to go in there and actually paint on the pores, and you can see all the detail that's there. You can generate displacement maps inside of Zbrush for all your stuff. So this is, that's a wrestler, isn't it?
Stone Cold.
That's what I thought. So this is Stone Cold Steve Austin. This is a high-res model. We couldn't open the high-res model inside of most any software. But what we can do is sculpt this really high detailed thing and then generate displacement maps, color maps, bump maps, and all this other stuff and apply it to a lower resolution one that we could render out, okay? They even have 3D displacement maps, which are like, they call them vector displacements, which basically take a flat image and it can pull out an entire shape. Typically, displacement or bump is just this direction. But a vector displacement can go basically in any direction, which is really awesome. So here is this flat plane. Here is a vector displacement map, just that image. And then when it renders, it looks like that. Okay? Because of how it's taking that data. This is just data, X, Y, and Z data, and it just pulls it out. There again, it takes a flat image, and then it pulls it out into that shape. Okay, so there's a lot of stuff inside 3D that is super in-depth. We're not going to touch on most of the 3D stuff. This is intro class. I don't want to scare you too much. Yes, ma'am. They do, yes. There's actually Modo. Modo is a 3D program. It's by the Foundry. And they have, just like this. Right? So somebody basically just creates all these vector maps and you can just paint them on. Like, here's an ear, here's this, here's that. It's pretty cool how they do it. But they have a plugin specifically for basically a community that allows them to create that kind of stuff. Even within Substance, even within Zbrush and all these other tools, there's communities where people will create stuff like that and share it. So for Zbrush, Central, this is one of the places where people share stuff. There's challenges, tutorials, whatever else. Where is that at? I was looking for the brushes. There we go. All right. So these are all different brushes that people have created for using inside of ZBrush. So if you wanted to paint like a scar on someone or a skin on someone, you can go to the skin area and pick one of these skins, and depending on what kind of skin you wanted your character to have, you could use these black and white maps to paint those. Now all of these, they're black and white, just like a bump map would be, because essentially what you're doing is painting on bump maps or painting on masks, using masks with all the stuff. And then you could sign up for other stuff too. There's a guy, his name was Michael something. For 20 bucks he had a deal. For lifetime, any brush that he developed, you could just get. So he has like crater brushes, skin brushes, horns and teeth and arms and legs and all these different brushes that basically you can just click and drag and it will add it to your character, add it to your scene. You can use ZBrush for anything, for basic 3D, like the basic 3D, like character 3D like Steve Austin, or you can use it for props. So here's a backpack done in ZBrush, here's a weapon, here's this lion, here's this. Okay, anything where you want to add a whole lot of detail to something, ZBrush is fantastic for, because you can get in there and actually put on, like, I want to paint the leather onto my jacket so it looks like leather, you can do that. I want to paint on the stitches so it looks like it's actually has stitches, you can do that in ZBrush. It's awesome. Cinema can't do it, Maya can't do it. You can fake it, but not as good as ZBrush's. Edge loops. Every time we model something, and we're going to start to see this starting on the next assignment more than this one, we want to make sure that we have nice edge flow around our objects, okay? And what that means is, let me delete this ugly thing. When we create a cube, a sphere, whatever it is, and we start inserting stuff with our knife tool, see how it's adding loops all the way around? Every single face, every single one of these polygons should be a quad, meaning that it's consisted or built of 4 sides. So 1, 2, 3, and 4. 1, 2, 3, 4. Every single face should have 4 sides, and 4 sides only. As we start getting into other stuff, let me not restrict the selection. We may use a regular line tool and go like this, and then go like that, and then go like this, and then go like that. And you might say, well, that looks fine, and it doesn't look fine, okay? Because now we have this face that has 3 sides, this face that has 3 sides, this face that has 3 sides. Now what that does is it breaks our edge flow. When we have something that is not 4-sided, our edge flow has now broken. And what that means is that now when I go to my knife tool, and I try to use something like loop, look what happens. My nice loop that went all the way around now does this like janky thing where it goes like there.
That's clearly a loop.
Right. Okay. Here it works, but because I screwed that up, it just, nope, it says no. Okay. So we want to have nice edge flow around our stuff. That takes basically a little bit of OCD. As you're modeling your stuff, making sure you don't have edges where they don't belong or crazy stuff like that. Extruding we've talked about is just pulling the surface in, pulling the surface out, pushing the surface in. Fall off is just a softening of the edges. When we have this, I'll show it Maya because it just visually shows it better here. Okay. When I click on a point inside Maya, I can turn on what's called soft select, which is basically softly selecting something, okay? So there's a fall off to my selection. So as I move this, it's not moving it like this, it's moving it like that, okay? So most things inside of Cinema will see some sort of fall off. Those linear things on our text has a fall off. It has a starting point, it has an end point, and all the stuff in the middle is that fall off transition. Lights, if they're not hard lights, they have some fall off. They have some softness to them. Okay? So that's what the fall off is referring to, is anything that softens the edges of it. Fresnel is the way that light bounces off of a surface and how we see reflections. So as you're stopped at a light in a car, maybe you're a passenger. Yeah, go ahead. You look at the car in front of you and you may see the reflection is not just like a mirror that wraps around perfectly, you may see the reflection is a little bit stronger on the edges and a little bit softer in the middle, right? You've kind of seen that thing before. That's what Fresnel is doing. 3D software by default just like reflects everything. Fresnel says, okay, now we're going to take into consideration the angle that we're seeing the stuff, and we're going to adjust for that, okay? Again, it might be good to see an example of that. All right, so here, this is a horrible reflection on the left side. You can see how reflective that is, like all over. On the right side, you get no reflection or very little reflection in the center, and most of it is on the outside of that object, okay? That's a more realistic reflection. If we're trying to get something to look realistic, we have to understand how stuff works in the real world. When they did Iron Man 2, that was where he had that like chrome suit. They actually had to go through, and it had a real world chrome suit. They sent it to the studio, and they figured out the exact reflection of each individual part, and then they applied it to each individual part in their digital version of that suit, so that way it would match perfectly. Okay. There we go. Global illumination, this is the light bouncing. So direct illumination, no light bounce. Global illumination or indirect illumination is that bouncing. This is something we would have to turn on inside of Cinema. Just like taking the anti-aliasing settings up, taking this up or even turning it on will make our rendering take longer, okay? Because of all the stuff that it's going to be doing. Let's see if we can get this to just show it. I'm just going to delete that. I'm just going to add a simple light. Okay, so if we hit Control R here, oops, let me take my anti-aliasing settings down. There we go. Okay, so what's happening here is the light is coming off that surface, and it's lighting up this one, this one, this one, and those two not so much, okay? If I go to my render settings and I go to physical, that's good there, that's good there, okay. And I go to effect and I turn on global illumination. Now what we're seeing is the light is actually playing a little bit more of a role and actually bouncing a little bit more, okay. Move it up a little bit more. And you can definitely see if I should have done this first one in there. Let me turn that off. Okay, so look at these corners here. That's really where you're going to see it initially. Is that. See how it's like just softening a little bit because we have a little more bounce from that area. I'll turn it back on and I'll make a little red item inside here. Whoops. Okay, now we'll really be able to see this because now we have a colored object in the scene. I'll make this even more vibrant so we can really see that. Color is good. Luminance. All right, now you can see a little bit more of the red kind of on that wall. You can't up there. All right, I'm gonna really like crank this crazy up just so you can really see that. It's 10 times as powerful. There we go. Now you can see that light's hitting the cube, it's bouncing off and now bleeding onto those walls, okay? Without global illumination on there, turn that off, we don't get that, okay? Now again, the more realistic we want something, the more bells and whistles we have to add to it, so it's just something to be aware of. Typically, if we are going to go super realistic, we try to keep everything super low until those end like phases, and then we can start cranking the stuff up. An HDR is a high dynamic range image. What's neat about an HDR is that basically you can recreate lighting situations. This is, for the next class, the modeling class, we use HDRs pretty much all the time. And we actually went and created one outside. Now this is a watermarked one. I'm still waiting for my other one to come in so I can not have a watermark. But basically what we did is we went outside and we shot pictures. Okay, so this looks very familiar. It looks like a 360, right? Or a panoramic of that scene. It's not just a panoramic, which just goes sideways. It's actually a 360 environment. So if you've ever seen the ones on Facebook where you can look up, down, left, and right and all that, that's what this is. But it was taken with a camera, shooting a picture here, and then here, and then here, and then here, and then all the way around. And then all those pictures were stitched together into this. Now I took several sets of pictures. So who studied photography? Good. Okay, so in photography you have different shutter speeds, right, on your camera. So one of these was taken at a 30th of a second, one was taken at 1/25th of a second, one's going to take it at a 15th of a second. So what are typically those settings going to do? If you take a picture at different shutter speeds, does it darken it, lighten it, right? It's going to change what the image looks like. So that's what that does. So I took all of those and it smashes all of these panoramics together into an HDR. And what it does is basically it's recording the light information for outside that specific day. So if we look at this one, actually didn't turn out to be a very good one just because of the I should have gone a little bit further on my ranges. HDR. Actually, I'll show the one that I have. I have another one. This one's 20 basic. Source images, desert highway, HDR. Okay, so this is another one. This is one you can actually download. This is again another 360. If I were to have gone into the desert that day and I snapped a picture of the sky, typically what's going to happen is it's either going to like blow out my lens because it's trying to balance for the sun, or it's going to really darken the sky or something. Okay, so it's always going to try to balance that. With an HDR, it records all the information, so if you see, I can see what it looks like when it's really dark, and I can see what it's going to look like when it's really bright, okay? Now this is different than doing like exposure or brightness and contrast. This is actually looking at all of those pictures throughout that range. Now we can take this and we can drop this into our 3D app and be able to actually put an item in the scene and get the same lighting that we would have had otherwise. When I'm in Substance, and I'm spinning around the object here. Let me just turn this off and I'm just going to add a fill color. Oops. And I'm going to take my roughness down. I'm going to take my metallic up. There we go. So this right here, the reason that this software is displaying the way it's displaying is because we can't see it, but there's an HDR that's helping light this scene. Okay, there's no lights in the actual scene. It's just an HDR that's kind of providing the lighting for it. So again, another bell and whistle that we can add to our stuff to make it look more realistic is adding HDRs to our scene for where it would be appropriate. Now, this HDR is a, you can see, it looks like a grassy area, foresty area. This one here is a desert scene. This one is Macombs campus. They have HDRs for everything. Okay, all of these are HDRs. Depending on what you want your object to look like, what kind of lighting, what kind of scene, what kind of whatever, that's the kind of HDR you could use for it. So if we built a robot, and I'm like, I want this robot to look really good, I probably wouldn't put him like in the desert like this or in a forest. I'd probably grab one of these so I get some really strong contrast in that image. Okay? Like that wouldn't look good for a robot. All right? There it is. So that's what HDRI is. HSV, most people have never touched Hue Saturation and Value, which is crazy. It's the best one. When you assign a material to something and you're going into the color range, Maya automatically defaults to it, which I love. But there's ways to pick it. I'm sure you've seen the Rgb sliders before. These ones here, where you basically are mixing red, green, and blue to get the color you want. This is annoying to me to have to do this. Like, I just want, like, let's say I'm here. I want a lighter version of this pink. Which slider do I touch? Maybe this one, and I have to play with that one, I have to play with this one, you know, or whatever. So the HSV is Hue, Saturation, and Value. So I pick the base color that I want, then I can just desaturate it, or overly saturate it, and then I can play with the value of it. So this makes your job as picking colors like 1,000 times easier than doing an RGB pick immensely, okay? So I typically stick to this. I like that the best. IES lights. So again, something else that we can add to make stuff look more realistic. Light manufacturers. Every light bulb has a specific way that it looks when it shines on the wall, right? So it's not just like illumination. There's actually like a pattern to it. So light manufacturers will actually give out what are called IES profiles. They're the light's profiles of what they would look like. So if I'm lighting a room and I want it to look like it's actually a real light, I would grab an IES profile for that light and drop it onto the light. So if you look at this here, these look like actual lights in a scene, like in the real world, because of how they're illuminating a little bit here and then more there, and there's kind of like this drop off and softness to it. You do not get that by default in 3D software. It just does not do it, okay? So you would use, again, an IES light to create that look. It's really cool. And they're really simple. It's just literally download it, drop it on the light, and then it's just a matter of picking the direction. Index of refraction. If you have a piece of glass, you look through the glass, and you can see how the straw is bent, right? So if you see a straw inside your glass of water, the straw goes in here and then it comes out there, kind of thing. The index of refraction is how much is being bent. Index. Oops, I just want refraction glass. That's what I want. There we go. So the straw goes in the glass, and then when it hits the water, it's bending. That specific material, glass, has a specific value of how much it's going to bend. Diamond has another value. Anything that is transparent has some sort of value for how much it's bending that image. That's what the index of refraction is. And again, crazy sciencey people have actually figured out what these numbers are. And if you go to Wikipedia, and you can donate if you want to. Index of refraction. They have an entire list of, if this is air, the index of refraction is 1. If it's water, it's going to be 1.33. If it's a diamond, it's 2.42. Okay? These are not hard set numbers. In the real world they are, but in 3D, they're starting points. Okay? So if I'm making water, I'm going to grab the water, assign a transparent material to it, set the index of refraction to 1.33, and then I'm going to modify it from there. If I want more, I'm going to go up. If I want less, I'm going to go down. Okay? It's important to know what those things specifically are. And just so you can see too, like, where's my cube? Nice. So if I go to this cube that I have here, that's crazy bright, and I say it's transparent, and then I render this out, it's transparent. Okay? If a piece of glass is transparent, I just turned on transparency, it is. What makes it look like a piece of glass, though, is, where was it at? Refraction. Okay? So that's the index of refraction right there. So if I set this to 1.33, and then I render this again, now we're actually seeing that shape. Now it's actually going to be distorting and bending the light inside there. The other thing that would make this look better is if it had bevels on it, right? Because no piece of glass is a perfect crystal cube. It would have to have some sort of beveling on it. And again, I will just bevel this real quick so we can see it. Hit C on there, click this. Actually, I didn't hit C. I can just go to my cube. I can fillet it. That should be good. And now again, it's going to start to look more like glass because we're adding more of what glass looks like to that shape. Okay. Cool. Indirect illumination, the light which is bounced off the surface. So the direct illumination is the light that hits the surface. The indirect is the light that's bounced after that. In some softwares, you can have it bounce 1 time, 2 times, 3 times. Each time, it's going to get weaker and weaker and weaker, right? So if I have a light that's like the sun, and this room is pitch black, it shines in the window, it's directly illuminating what's in front of it. And then the ceiling, which is obviously not facing the window, would get some light. That would be its first bounce. And then the second bounce would be what happens after it hits the ceiling. It's going to light up these walls, let's say. That would be the second bounce, and then what happens after that. Each time it's going to get drastically lower. In some software, you can specify I only want 1 bounce or 2 bounces. Again, the more you have, the longer it's going to take to render. Interpolation is just how it moves from one item to another. So you set a keyframe at 0, you set a keyframe at 100. The interpolation is what the software is doing in the middle. Okay. Keyframe, I say I want the camera here, and then I say I want the camera here. Those are the keyframes that would go into that. What happens in the middle is up to that interpolation. You could have it go, like in After Effects, you could have it go super quick, super slow, straight, linear, whatever. If I took my cube here, back in object mode, there we go. Okay, and I set a keyframe on its Y position, then I go up to 90. I moved it up. Set another keyframe. It moves up. I go in the middle. Oops, I can't go in the middle and move it. Okay, so it's going basically at 1 speed, right? If I right click on this and I go to the show F curve, this is going to show me a curve. So if you've had After Effects before, this is like the speed graph. So that's how it's animating. This here, as it's kind of like flatter, that means it's going to go slower. The steeper it is, the faster it's going to go. Okay, so if it's like this, it's going to go super quick. If it's like that, it's going to go super slow. Okay? So if I grab these handlebars, and just like you would do in Photoshop or Illustrator, you can kind of manipulate that shape. Why are these both selected? It's not one. Okay. What I'm doing is I'm changing the interpolation of it. I have my keyframes, which are on each side, and then I'm changing the how it's getting from one to the other. So this should go super slow and then super fast, like super duper fast. So watch it now. So fast you can't even see it hit the top. Okay, so we can change the interpolation of our objects. And what's neat about cinema, this is one of the cool things about how it animates. See all the dots that are on that line? All of those dots are each one of my frames. So if I look at it, I can see there's a bunch of dots bunched here. It's going to go slow. The dots are further spaced out here. It's going to go fast. Okay, so that's a really good indicator when you're looking at it to see how fast things are going to move. Keyshot is a 3D rendering software. Okay, so for our room, we animated, we modeled, we textured, we did whatever. We rendered everything out of Cinema and then brought it in After Effects. We could, on one of our projects we will, model something and then take it into Keyshot to do the rendering. And Keyshot is strictly just a rendering program. And what's neat about it is how it renders the stuff, because it does it more in a real-time fashion. Okay, so this right here, this camera, we modeled this, let's say in Cinema. We brought it into Keyshot. I say, okay, I want black plastic. I drag my black plastic material that's like their preset, and I drag it onto the Nikon camera. I drag it onto the lens, or onto the lens there. I need this glass, so I grab the colored glass and I drop it onto the colored glass. I need this red band. I grab that red band plastic and drop it on there. And it's showing me all of this stuff in real time. As I spin around my object, I can see what it looks like. In Cinema, every time we want to see what this is going to look like, we have to hit that, right? We have to hit Shift-R or Control-R to actually see what the rendering looks like. In Keyshot, you don't. It just automatically updates every single second. And it has realistic lighting in there, very similar to what Substance does, but it actually looks a little bit better than Substance. Okay. Lathe or Revolve. So if we had a curve inside of Cinema or 3D, any other 3D software, create spline. It's gorgeous. I'm going to go here, switch to my move tool. Okay, so if I have an item here, I can go to my, where are you at? Sweep, no, lathe, there it is, and drop this into lathe. Okay, now what it does is it takes that curvy shape and it does a lathe on it. It does a revolve on it. Okay, it basically takes it and duplicates it to create that shape all the way around it. So you can use this as a starting point. If I'm making a glass, instead of starting off with a cube for a glass, I could just go in with a curve and draw what it would look like from the side view of the glass, and then use this lathe to create the actual glass shape itself. Okay, and the benefit of that is I can turn this off, go to the points, tweak the shape. You'll see those handlebars just like in Illustrator, right? Cool. Yep, that's all you need to do is use that pen tool. Always draw it from the side, front, or top view, okay? And then when I have it here, it's under the lathe. So I make sure I drop it into the lathe so it's underneath it. And then there it is. I can tweak the shape all day long, okay? Maya calls it a revolve, Cinema calls it a lathe, okay? Same tool, same exact settings, it's just, that's what it is. Layers are ways to organize stuff in 3D. Like we talked about before, they don't mean anything as far as what stacking order things are in. It's just visibility, non-visibility, and then some other settings. Mari is a software used to paint textures. So before we got Substance, we used to paint all of our textures in Mari. It's a really good program for doing characters. So like something like this, I could paint those textures in there. You can actually bring in a picture of blue scales, and then as you see your character, you just basically paint on top of it. You rotate your character, paint on there. So imagine it more of like you're painting stencils or you're clone stamping onto a 3D model. It's pretty awesome. Maya is another 3D program very similar to Cinema. I use it for creating more realistic 3D assets. Mesh is just another name for polygon. Okay, so just the objects we've been creating have been polygons, so you can also call it a mesh. Some softwares will call it that. Mudbox or Zbrush. I talked about Zbrush. Mudbox is a free version of Zbrush from Autodesk. It does something very similar, not exactly the same. There are some limitations to it, but if you wanted to start playing with a sculpting program, I would download Mudbox because it's free. Zbrush, there's no student discount or anything, or student freebie available. A node is just a generic container which can hold different kinds of information. What that means to you is in Nuke, in Cinema, in Maya, anything like this is just called a node. Just like these little blocks, that would be something that you're having information. So if I add a grade node, that's what that is. If I add a color bars node or a hue correct node, that's what that is. Inside Cinema, you're not going to see them too much. The closest thing that we're going to get to it in this class are the hypershade or the shaders here. We call those just shader nodes. Okay, it's just a box that contains all that information. Depending on where you're playing with these things, you could have objects and all their properties listed inside of a node, or you could have just like a couple properties in there. Okay. Nonlinear animation. So this allows you to animate a point here and a point there, and then it automatically will fill in the rest for us. If this was linear animation, we would go frame 1, frame 2, frame 3, frame 4, frame 5. We would have to go that way to do that, okay? Nonlinear, we can go here, and then we can jump back to this, then we can jump here, then we can go way back over here. We can bounce around. That's all that means, okay? All the stuff in 3D is typically nonlinear animation. All the stuff in After Effects is typically nonlinear animation. The only kind that would be more of a linear animation style is if you're doing frame-by-frame animation stuff. You guys probably don't remember this, but there's VHS tapes, okay? When you did edited VHS tapes, that was a linear animator, or linear editing, because you would put it in the thing, and you'd have to play one, record on the other, and then when you're done, you would pause it, switch your tapes, and then do that again. There was no way to say, I want to take this chunk out and move it over here, and take this chunk and put it back. It was impossible. Maybe if you cut the tape, I guess. But normal. So a normal is a direction of the surface. Cinema does a good job of not really having to worry about the normals for the most part. Like in Maya, this surface has an inside and an outside, okay? The normal is what tells it which side is the outside or which side is the inside. If I go to my polygon and I say, let me see the normals, you see these little green things sticking out? That's showing me this is the outside of that face, okay? Now why this is important is when you get into stuff like glass, it has to know what is the outside of the glass and what is the inside of the glass. If it doesn't, it won't know how to render it correctly, all right? Also, some properties won't work correctly too. Like if you had a ground plane and you had a ball bouncing, it could actually detect the top of the surface, but if the surface is upside down, it'll actually just go right through it. Okay? So you have to know at least where the normals are for that kind of thing. Maya will just show you the bottom side is black, and then the other side is whatever color you've chosen. Nuke is a compositing software, so you can use Nuke to composite stuff. So basically in this class, we're going to use After Effects for all of our compositing. We render stuff out, we bring into After Effects, and then we're done with it. Nuke is another way that we could take it if we wanted to do more stuff. The passes that I talked about at the beginning, where we were dealing with the color, the different lighting passes and the shadows and reflections, if I was going to do that, I would go into Nuke to do all of that stuff. Nuke is probably one of the top compositing softwares out there. Even people who used to use After Effects for their compositing now use Nuke, just because of its ability to quickly change stuff. We don't need to get into a huge discussion about it, but let's pretend that I did some grading to this, and then I did a hue correct, and then I did a light wrap, whatever. Okay, so these are all things that I may have done to this specific piece of footage. And then let's say that this piece of footage changed. If I was in After Effects, I'd pretty much have to go through and redo all those steps again. If I was in Photoshop, holy cow, I would have to redo all those steps again. In Nuke, I just go like this. This is my new piece of footage. I go there. Okay, so that's a huge advantage to using something like Nuke. You could also grab stuff like this and make a little plugin, like with 2 or 3 button clicks, which is awesome. That way someone down the line can just say, I always do these same 5 steps. I just want to make a button that does it for me. Okay. Super friendly. Even Photoshop, sometimes I use Nuke over Photoshop just because of how quickly I can do the same process on 4 or 5 or 100 different photos. A null is just an empty object. If you group something together, it creates a null and drops your stuff into that group. Just so you can see, if I don't have anything selected, I hit Alt-G. It doesn't do anything. If I click something and Alt-G it, there's a null and there's that. You can also go to Create Null, and it'll just make an empty null. Maya calls them the same thing. So if I don't have anything selected and I just group something, it makes a null. Okay? Or if I grab these and group it, it actually does call it a group, but it's the same thing. Okay? It's just an empty thing empty container to put stuff in. A pass or a render pass. These are ways to take your rendering out at the end and split it up into different things so that you can tweak it afterwards. You may want to add ambient occlusion. That's a render pass. Okay, we typically don't render it inside the software because we may want to tweak it afterwards. It may be too bold or contrasty. We may want to adjust our reflections afterwards, so we can render that out. We can adjust our colors afterwards, we can render that out separately. There's not a limit to the number of passes that you can have. It's just a matter of what you want. So here are just some common render passes for different things. So here's the beauty. So this is typically what you would see at the end. Here's a depth pass. This is basically from the camera to the farthest item in our scene. How far is it really? Okay? And we can use that to create depth of field. You know how real cameras, you get close to something, you take a picture, and you get that depth of field effect? You can do that with 3D by rendering out a depth pass. The ambient is just the overall lighting, ambient raw, some other stuff, ambient occlusion. Here's our color, diffuse no shadows. A whole bunch of stuff that you can play with after the fact. When they did District 9, they actually rendered out a pass that allowed them to relight and retexture their creatures inside of Nuke afterwards, which is awesome. Photoshop, you know what Photoshop is. We are going to use it to create textures, to do paintings, and manipulate or enhance images. So the common question, I have a piece of brown wood. How do I make it red inside of Cinema? Any ideas? You go into Photoshop and you make it red. You bring it back in. Okay, that's it. Simple. Okay, so don't be afraid to use Photoshop for this class. Physical rendering is a way to, again, kind of push it so that our rendering looks more realistic. You can add things like depth of field. You can add things like motion blur to your scene. Let's go back to... Let me just delete all this stuff. I don't want any of that. I'm going to do a cloner here. And with this cloner, this is very similar to what we're doing now. I'm just going to change some of my directions. There we go. Alright, so now I just have a bunch of cubes, like that. Alright, so there's my cubes. Now, what makes this look super CG is the fact that everything, no matter how far it is crystal clear, right? Even the object that's really far away is still sharp. If this is an actual thing that we photographed or videotaped or whatever, there would be some fuzz to it where the objects that are further away are definitely softer. So, turning on our physical render, we can turn on depth of field. And what this will do is it'll actually figure out where we want our focus distance, and it'll go and start blurring stuff. Okay? Now, by default, it's not on everywhere. I turn it on in physical render, but my camera also has to have it. So I'm going to create a camera. I'll look through my camera. And then under the physical, field of view, focus distance, there it is. Under focus distance, I'm going to click on this arrow and say there. And so what that's going to do is allow me to focus on that specific item. Now it's still not going to do it because I have to turn on some other settings, which is make this a movie camera. And then start to play with this f-stop. 1. There we go. Okay. So it's subtle. Let me zoom in here so you can see it. You see how now we're getting a little bit of fuzz on that back area. Now I can take that even further by taking this number down some more. So if I take this to, let's say, 0.5, I'll just go crazy and do 0.1. 0.1 is a huge change in this. There we go. Now we have some really big depth of field on here. That first object that I clicked on is crystal clear, and then it drops off. Okay? That's what physical rendering allows us to do inside of Cinema. If we don't have this physical renderer here, then we're dealing with strictly software rendering. Let me close that. And then that's all we get. Okay, there's no depth of field back in there. Okay. Cinema 4D has its own rendering engine. The physical rendering one is like a second engine inside of it. There are other softwares that have different rendering engines. All of those are basically pieces of software to figure out what's the best way and most accurate way to light things. Octane is one that Cinema uses. Maya has several. RenderMan, it has Maya software, Mental Ray, V-Ray, Arnold. There's a whole bunch of different engines out there. If you get into 3D and you're working at a company, they will have a rendering engine that they've been using most likely, and you'll just kind of adapt to that one. They're all very similar. Some have limitations. Some are better than others. You just go with what you have. A quad, like we talked about, is a 4-sided polygon, 4 edges all the way around it. Rendering is a method of taking the objects and actually making it into something. So it calculates the lights, the materials, the reflections, the refractions, all that stuff, and puts it together. RGB is red, green, blue. Computer screens are red, green, blue. Printers are Cmyk, right? Sampling is refining the elements on scene by examining specific aspects. So our anti-aliasing settings here, standard, that's why it looks so horrible. These are different sample settings for what we're looking at, okay? So the more samples, typically the better the rendering, but again, the slower it's going to be. This is important for us to know. Let's say that our shadows are looking kind of grainy. We probably have to take the samples up on our shadows so that they don't look so grainy, okay? Snapping allows us to snap to specific items. So in 3D, there's a whole bunch of different snaps, not just like pixel snapping left and right. You can snap to objects, edges, curves, grid lines, anything. A whole bunch of stuff. Subsurface scattering is like on a character. You ever see the light pass through behind someone, their ears kind of light up? That's subsurface scattering. In our ears, it's very prominent, but the whole characters typically have that, where light will hit, and it does kind of like illuminate certain areas of our skin where it's thinner. So like around here. Again, this is, if you want skin to look like skin, or you have like a piece of jade, that's another popular one, or milk. Anything that's solid but light goes into it and kind of bounces around. In order to get that, you would use subsurface scattering. Typically, you would use a mask or a map for it, because nothing is pure in how it scatters, right? So like a piece of glass, if you had an absolutely perfect piece of glass, the light hits it and it shines and whatever else, sure. Most glass isn't, though. Most glass has some kind of like distortion to it. There's a little bit of bump to it, or a little bit of scratchiness. All of those things go into making your stuff look more realistic. So all of these are examples of subsurface scattering. Texture map. If we want a picture inside of our stuff, we want something to look a certain way, we would use a texture map. We could use it for color, for bump, for specularity, for reflection, for anything. Substance, what this is doing is actually generating all of those things for us. So here, this is what the end product should look like. This is what the bump map looks like. This is what the roughness map looks like. This is what the metallic looks like. This is what the color looks like, okay? So, depending on what you want, you may need certain texture maps. In some cases, it's just going to be color. Like when we get to our serial box, it'll just be color. When we get to something that looks like a person, we may need a color and a bump and maybe a roughness patch or something, okay? Topology is just how all of our points are laid out. If you look at the wireframe of a person, notice how these edges flow nicely around the character. That's the topology. That's what you want to have when you model something, is nice flow around it, okay? Same thing here, nice flow around it. Your topology should flow with basically what you're trying to model. So if you look at this character here, let me view. Notice here how where the ribs are, where the ribs come up, the topology is flowing upwards from here. And then around the shoulders, it's kind of rounding and then coming down into those muscles. So that needs to be how your character is built, what you're going to see. That's how your topology should be flowing, okay? And it may sound silly, but again, that OCD has to come in to make sure that that is happening. If you get too far ahead and you start adding divisions where they shouldn't be, then your stuff isn't going to flow nice, and then everything will look horrible. Just for fun, let's see if there is an example of bad topology. There it is. Here's bad topology. See the lines and how they're kind of like jaggedy up here, and same thing down there, same thing here. This is nice and smooth. That's what you want, okay? Especially for if you were to animate this character, where these edges are is important, because if I want him to blink, I need to make sure I have nice edges in the right position in order for that blink to happen. If you get into like human modeling, they go really crazy. And we'll talk about this more later in the class, but you would actually study like face muscles, so that if you're trying to capture how an eye blinks, you have to understand the underlying structure of all the muscles that go into that. And they do. They actually build, when they model good characters, they will build the muscle structure, or the bone structure, then they will build the muscles on top of it, and then they will build the skin on top of that, in order to make sure that everything works together. And then when they take it to the animation part, all of those will still work together, right? So just as an example, as you turn your wrist here, this skin actually turns, but that skin doesn't really turn. Because of the muscles and because of the bones that's in there and how it works, they understand all of that and can apply it to their models, okay? Triangle is a three-sided polygon. Rarely should you ever use a triangle, okay, anywhere in your model. You can have, if you look at the good example here, everywhere on this model is rectangle, or is quads, four-sided. If you look at this one, there's a triangle right here, there's a triangle right there, a triangle there, bad stuff, okay? The reason for it is that triangles will typically create pinches, okay? So when you have a character and you smooth them out, you'll basically, like, here's a nice smooth area, you'll get a pinch right there, and it looks disgusting. So you want to make sure it's quadded so everything looks nice, it blends nice together. People have tried to do it on cars, same thing. Cars are super important. You get a reflection. If you ever watch any car commercials, they always like turn the car and they get these nice reflections that slide across it. If you have a pinch in that reflection, it's going to look funny. It's going to look like there's a ding in the car. Unreal is a gaming engine. You guys have probably heard of Unreal before. When you start your games up, it says, you know, produced by Unreal or Unreal supported, whatever. It allows you to take your 3D models into it. It's actually free. In our modeling class, we actually use Unreal so that people can take their 3D models and they can render them out and actually have something that is a flat image or something. But we also have them in Unreal so you can actually interact with it. So I have a, what do we do? A room, right? We did a room already. I can take that room and drop it into 3D and have my character walk around that room or into Unreal. Vectors or vertices, those are just the points. Okay, so these guys right here, the little points on there, that's what those are. So Cinema calls them points, Maya calls them vertices, same thing. Z-depth is that grayscale image. Sometimes they show it as red. Okay, so this is the one of the render passes that shows from the camera to the farthest distance of how far it is. Okay, so where it's white, that might be 100 feet away or 100 units away, and where it's black, it's probably like 1 unit away. Okay, but this is a render pass that actually will render out how far an object is. And what we would do with this is we would use this to recreate depth of field in our post software. Okay, so I would go into Nuke, and that would let me create depth of field there. Or I would go into After Effects and it would let me do it there. Or Photoshop would let me do it there. The benefit of doing it here instead of doing it inside of Cinema is I can't change it after I've done it in Cinema, right? So your rooms took probably an hour at the most to render out. Our later projects, like the one that you're currently working on, the title, you'll use depth of field in the software and it's going to take probably 20 hours to render out, okay? Depth of field in post takes, let's say it takes 5 hours to render out. If I need to change something, I can change it in post very quickly. But if I render out 20 hours and doesn't work, I have to go back and re-render out another 20 hours. And if that doesn't work, another 20 hours. So if I render out a depth pass, I can change all that stuff inside of post, which is handy, okay? I believe that's it. Cool. All right. So a lot of these we'll be touching on throughout the semester too, but I want to make sure you had some sort of introduction to them before we get into the actual definition test on Monday. Okay. So any questions on specifically what those were? No? Okay.